let's talk about finding the horizontal or the oblique asymptote of a rational function. So let's start with our horizontal asymptote. These asymptotes are going to be drawn left-right as dashed lines, and they're going to be in the form y equals some number. Right, again, your asymptote is a line where your graph is going to get real close to it, but not touch it or cross it. The other type of asymptote that we have here is called the oblique asymptote. And your oblique asymptotes are ones that are also referred to as your slant asymptotes. I'm going to be abbreviating the oblique asymptotes as OA when I go to write them. Your oblique asymptotes are going to be slanted either uphill, or they could be slanted downhill. When we go to draw them, we'll still draw them as dashed lines on our graph. And your oblique asymptotes are going to be in the form y equals mx plus b. So let's go ahead and take a look at a couple cases, and we'll talk about some distinguishing characteristics here. Case 1 is going to be when the degree of our numerator is less than the degree of our denominator. So we've got our function here, r of x equals x minus 12 on top, and 4x squared plus x plus 1 on the bottom. So if we take a look at this function, let's take a look at our numerator first. Right. The highest exponent with that polynomial on top, the x minus 12, right, would be a degree of 1. If we take a look at our denominator, our leading term here is this 4x squared, where our degree is 2 for our denominator, right? So this fits the criteria for case 1. The degree of the numerator is less than the degree of the denominator. And this is actually one of the easiest cases. It's automatically going to have a horizontal asymptote. And it's automatically going to be the line y equals 0. So I went ahead and graphed our function so we could take a look at it. The function r of x is graphed here in blue, and you'll notice that our horizontal asymptote here is graphed at y equals 0, which is actually the x-axis. You'll see that there's a purple dotted line there. It's a little hard to see on our grid, but it'll lay on top of that x-axis piece. Let's go ahead and take a look at case 2. Case 2 is where our degree of the numerator is equal to the degree of the denominator. So let's go ahead and work with a different function here. This time we've got r of x equals 8x squared minus x plus 2 on top, and 4x squared minus 1 on the bottom. So the first thing we want to do is go ahead and identify the degree of the top. The highest exponent up there is a 2. And degree of our denominator is also a 2. Right, so we want to make sure we find out, does this have a horizontal asymptote or an oblique asymptote? And these graphs can only have one or the other, right? They're never going to have both. In this case, it's going to have a horizontal asymptote. And the way we find it for case 2 is we're going to go ahead and take a look at our leading terms. And that's going to help give us our equation here. So our leading term on top is the 8x squared. And on the bottom, we've got 4x squared. And we want to go ahead and just simplify this. Right, the x squareds here are going to cancel each other out, and 8 divided by 4 is going to give us 2. So our horizontal asymptote is going to be the line y equals 2. So I'll make a note here that you want to go ahead and use your leading terms to find your equation. If we take a look at our graph, you'll notice that we have our horizontal asymptote graphed up here at the line y equals 2. And our function is actually graphed in blue. You'll notice this one has 3 pieces total. 2 of them, it looks like, are up on top of that horizontal asymptote, and then you have a small piece here towards the bottom of the screen. As you're looking at these graphs, you'll notice that those lines of your function are getting really close to those asymptotes. If we scroll out, you'll see that they never actually touch them. They just keep getting closer and closer to them.